Hello and welcome to another Solana tutorial about compute unit optimization. Yeah, I said I'm gonna do more videos on that topic, so here I am making more videos on that topic. Why is that important? Well, first of all, each transaction is limited by compute. So the more compute an individual instruction takes, the less other things you can do in the same transaction. And you can request more compute for your transaction, but that also has an upper limit of currently 1.5 million compute units. And so at some point you can't do more, right? It limits composability if an instruction needs a lot of compute. It limits the amount of CPIs that you can do. Or if another program CPIs into your program. You want a CPI into programs that use less compute. If you can choose between two equal programs and one uses less compute, you're gonna use that one. Well, okay, let's not generalize like this because there are also other considerations like security and whatever, but still, that's the one reason. Transactions just having a limit. But then also blocks have a limit. Both on the total compute, so it's good for Solana if your transactions are smaller because then we can have more throughput, we can have more transactions per block, but also for you as a program developer, you want your program to be efficient because there's also a compute limit how many compute each single program can use per block. So once you get to that point where your program is used a lot, you might reach those limits. So it is good to optimize for compute units and use as little as necessary. Of course, I'm not telling you to sacrifice security and not do checks because they use compute. No, that's stupid. Of course, you want to have all the code to make your program actually work, function correctly, but you don't want to waste compute units. And there are some things that can be optimized simply by knowing them, some best practices on how you can save on computes. And that's what we're gonna have a look at today. This video comes to you in two parts. Part one, I'm gonna build a program that will later optimize. That is not ideal, such that we can, in part two, optimize that program and have a look at what are the things that we can optimize. So let's get started with part one and writing a program that is not good. I'm gonna choose an anchor program, and writing a not ideal program is pretty trivial because no program will be ideal. But then during this exercise here, I'm purposely putting in some, I would almost call them mistakes, or I will not write good code. And we will see. I imagine that partly this is going to be really difficult for me because I'm like, I can't even see this myself, but we will see. I'm gonna attempt to build a Solana program that we can later optimize. And such that there is a lot to optimize, I'm gonna, make a lot of mistakes now. Here we go. The program should still do something productive. So what kind of program do we write? There's always the difficult part coming up with creative stuff. We are going to create a program that just persists a memo. Yeah, why not? Like the memo program, except it doesn't only log the memo, it also saves it into an account. Something really simple like that. Because it's so simple you can't get that wrong, right? Let's see how wrong I can get that. Okay, yeah, we will definitely need an account, memo account. Wait, is it big enough? Should I make that a bit bigger for you? Oh, and by the way, if you watch this and you're like, no, please don't do it like that, that's great. That's exactly what I want. Because then you're a good student. If you point out all the mistakes while I write them, write them down. Be like, yeah, I would have done that differently. Yeah. I will purposely make mistakes. So now I need to talk about something else so that I don't make the first mistake right away. Right, there will be an initialize. There will be a memo account. I don't know how big it's gonna be, so I'm just gonna say, let's make a max. Random U. Yeah, almost 7. We said we're gonna write a bad program, so this is how we do it. So then we will see what else we need. So for now, I'll put a 32 here because I'm not sure about that yet. This is absolutely not how you should program, but I'm purposefully writing a really bad program now. Okay, anyway, so that memo account, what does it need to store? Well, obviously the memo itself, that's the most important thing. And we make it a string. And then the owner is a bad word, creator, authority, and then maybe a state, like if that memo is successful owner, right? Some state of the memo, yeah. Maybe the authority can invalidate that state. Yeah, so let's make an enum for state. Uninitialized, initialized, valid, invalidated. I'm not creative, but those are my states now. Yeah, something like that. Can you build that for a second and tell me? That's fine. But obviously you didn't like that because this needs the memo context. So, store memo takes the memo context and the memo, which is a string. Program started. Successful. Yeah, and that built successfully. Wonderful. Do I want a nicer program ID? There we go. So the CU optimization, what does the program actually do? It writes the memo into the new account. Okay, let's make several instructions. It's okay to have one for storing the memo and then one for validating it. Oh yeah, we need to save the status. Okay, since I don't know how that works, I'm just gonna make constants. That's safe, right? What could possibly go wrong here? Do you now know initialized? There we go, problem solved. Okay, we store the memo and we validate the memo. Oh yeah, we also need to save the owner. From the context, the signer. Key. Yeah, that. Ah, too bad. It says mismatch types. What is going on here? Try using toString. Okay. toString. There we go. That fixes it. Safe. Yeah, I mean, it is a string down here, so it is a string. Yeah, that makes perfect sense. And then for the validate, we need to check that memo. So if the context account's memo account state is uninitialized. So if it's uninitialized, we say it's uninitialized. However, if it is valid already, what else? Well, if it has been invalidated, invalidated. Ha. And then, and only then, we can validate this memo. So, what do we do if we validate this memo? Well, context accounts memo state is valid. To do, actually validate it. Let's worry about that later. What else do I want? Yeah, fine, let's continue here. So the first thing we need to validate is validating the owner of the, I'm telling you, I'm writing a bad program, I'm calling it owner of that. So I need to check if memo authority equals the signer of this one. So the context signer key toString. Then I can say owner valid. Else, guess what? We're gonna need an error again. Memo owner doesn't match. Well, that's a horrible name, but whatever. Okay, I just remembered I forgot to check something in the beginning, and that is that memo is actually within the allowed size. So I need to figure out how long the memo is. 4 character in memo. And then we have the memo length. And if is larger, then there we go. Does it build? Nope. Shit. SU size, because that's safe. Should I be stupid and also have like functional errors in here? Probably not. But see, the thing is, if the memo, that's not nice, is it? Yeah, you know what? This is gonna become a U64 then. Oh yeah, down here it doesn't like that. But down here I know that my max, that thing, I know that I can safely cast that as U size. So that's fine. Okay, and then the equal thing doesn't consider borrowing. Okay, yeah, you need a reference, that's fine. There. I like to have it all in one line, but it's auto-formatted this way. Fine. Okay, does it build now? Yay, it builds. Okay, what else can I f up? If the memo is short enough, I'm gonna also log created by, this is the guy who created it, and then the memo. Okay, let's validate that memo. What does it mean that a memo is valid? Well, for one, the signer once again confirms that he wants to validate it. I mean, okay, you can do that both in the same transaction, so actually it's fine. So first you create it and then you validate it right away. But also, I'm gonna only let you validate memos that are alphanumerical with spaces. So I don't allow memos that have special characters. Yeah, that sounds about right. Let's do that. And I'm gonna make myself a function such that it's clear. Function is memo valid. It is valid memo. I think that sounds better. If that's a valid memo, what do I need? Well, the memo. So string. And now I need to implement that thing that I just said I would do. I mean, I know what my efficient solution is, and now I'm thinking of can I make this inefficient? How can I make this most inefficient? Hold on. Forget this. I in 0 to memo length. We can make this way more inefficient. And then let the character be at I. Oh, get I. Then I get an option. Hold on. I can unwrap that option. Yes, we wanted to make it inefficient. Here we are making this inefficient. Hold on. We'll get there. Hold on. So, memo, characters, and I unwrap. Oh, I love how stupid that is. Okay, so what's that type now if I don't type it? Character, perfect. Ha! Builds. A monstrosity of inefficiency, but builds. I'm gonna love optimizing this. So, we have a character. What do we do with that character? We need to check. Yeah, there are nice functions for that. I love it. Is alphanumeric. That's what I want, right? It is alphanumeric, or should I also allow punctuation? White spaces, but I want to be more specific than white spaces. I want to be like very specific, a space, like not an enter, not a line break, but just this. Does that build? What's the difference between a character and a string? In Java, it's that. Ah, there we go. Okay, but if that is the case, it is alphanumeric or a white space, like a space, then yes, you are a valid memo. Otherwise, I say no, you are not. So this thing here returns a bool. And then I can call it up here. Oh, valid? Yes or no? I just call is memo valid from the memo account memo. Does that build? No, it does not. Cannot move out of a dereference. Move occurs because value of type, you can't read that. Move occurs because value of type string, which does not implement the copy trait. Well, that's unfortunate. Can't just copy this, but I can clone it. And that will fix it. Easy. Just make it work. I love building stupid programs. Anyway, it's great that we logged this, but then we should also maybe check that we make sure that that's the case. Because if it is a valid memo, wait, no. If it is not a valid memo, then I'm gonna error. Memo contains invalid characters. Wonderful. And should I make it really stupid and obvious that I'm doing stuff wrong? Because if it is a valid memo, then we're gonna store it that way. Isn't that line wonderfully useless? Yes, it is. But we will figure that out later. See, there are some obvious mistakes and there are some not so obvious mistakes. I hope that at least the obvious mistakes you see cause the function 3 times. Idiot. So, are we done now? Is that like, are we done with the memo? No, I'm not quite happy. I want to still do something more. One more thing. Yeah, let's make the memo account a PDA. Because it should belong to the program anyway. Might as well make it a PDA. Okay, it's good to reiterate. How do PDAs work in Anchor? Seeds, memo, the signer, as bytes, or something like that. And then, because a signer wants to have several memos, possibly, I want to also add an index or something. I don't know, U32, whatever. So here I'll do a memo index U32, and it's just important for the PDA. So memo index, and this I think I need to do as bytes. And then I also say I want you to derive me the bump automatically. Canonical bump, will that do? As bytes found for type current scope as ref. No as ref. Oh, come on, what do I do then? What does it have? 2, there, 2 little endian bytes. That sounds about right. Mismatched types, oh you mother. Consider borrowing. Well, thank you for that genius idea. I shall do that. Yes, builds. Easy. And then of course we need to do the same down here. For that memo account, we need to once again say that it's derived with the signer and this memo index. So we need to once again also have this memo index in the instruction here. Okay, but that should now do the trick. Cool. Warnings that this memo index is never used. I mean, yeah, fair enough. We can do that. I think it doesn't matter how I call it. Because here it doesn't matter how I call it, it will just reference the first thing from the instruction data, so that's fine. Now build without warnings. Wonderful. And now that we have a wonderfully inefficient program like this, we can totally connect our wallet and deploy, which on DevNet is really freaking fast with SolPG, your favorite Solana web IDE. Yeah, cool. Step 1 complete. Welcome to part 2 of this video, where we actually gonna learn about compute unit optimization. Well, but what do we optimize, Andy? Let's at least check, if we just run it, how many compute units it would take. Yeah, so let's build the front end that will then run me this thing. And I think I want to do that locally. I mean, I could test with this, right? I could just store me a memo. My first memo, hey there. That's, I think, how the memo is derived. Generate that. Let's test. I think that would actually go through. There we go, that actually goes through. I can create a memo. Yeah, pay for the memo account. That's the memo account. And it consumed 33K compute units, which doesn't sound like much, but it's not nothing. And then I could validate the same memo by putting again the 1, that memo account, and I test that as well. That also works, and I get 20K compute units for the validate. Oh, but something in my validation certainly doesn't work here. H. But the memo is valid. It's just not particularly correctly valid. So not only do I write inefficient programs, I also write incorrect programs. Functionally wrong programs. Oh, our classic logic error. Of course, I should only return false if that is not the case, and return true if it is the case. That's an error that I didn't even put in there on purpose. Better fix it right now. There we go. This memo has already been validated. I mean, I wanted to say this later, but I can say it now because it doesn't really optimize for compute units, or at least not significantly, not really, I think. This else is pretty useless here, and it just causes ugly code because I have so many indentations here now. I can just leave out that else because in every of those cases I return the error anyway. So I can leave out that else and just have them on that level. Then that's way nicer. And then that thing with commenting this thing out, rebuilding and upgrading would actually work, because that's how I usually write my code. Those guards on top and then on the same level the remaining code. I error auto, I return right away. Yeah. Now test again. Yeah, that's what I want to see. Now it checks all the characters properly. Good that I added the logging. Hey, the logging is actually really helpful. Otherwise I wouldn't have recognized that there's an error. But we already see that I'm doing a bit too many checks. But let's not worry about that. Yeah, so we could deploy and I can test with those things. But first of all, I would like to test both of them at the same time. And secondly, I would also like to just do some simulations so that I don't always have to, go here and check how many compute units were consumed. There we go, 33K. Now at the end, this also took 32K. We saw, if I'm doing it right, it takes more compute because it does more things. And that's already the issue. So we want to be efficient with our compute units. So the goal is now to optimize this code to use fewer compute units. Export the IDL somehow. Can I get the IDL? IDL. I see my errors, I see my count structs, and I see the instructions. Wonderful. I don't see the program ID, but that I can manually enter somehow. So do I remember how Anchor works? I mean, I really prefer to just call my programs manually with building the instructions manually, but since I have an IDL, I might as well use that. Oh, and I wish I could create the IDL with seeds on. Yeah, we're gonna do that. After 40 minutes of messing around with freaking dependencies, I now have a local build of this Anchor program, and it calls it Hello Anchor. I think that's the default export name for the Solana Playground export. Do I remember where I need to say seeds? Yes, here where it says false, I say true. And then I'll do that again, and then has the PDA seeds in here as well. Wonderful. That's exactly what I need. And then I can write the client. That took way too long. But we can call a connection. Great. We have one sol. Amazing. Okay, now let's actually call that freaking program. Store memo. And that should actually be sufficient to get me the instruction. Then we do the same thing with the validate memo. Same index. The rest it should derive itself, then push that into a transaction, send it the old school way, because I can't be bothered to freaking do it differently. Just want to simulate transaction anyway. There we go. That's what I want, to get the number of compute units consumed, which is 69,000. That's a great number. But it's also a great in the sense of high number. So we want to get that down. And for that, we got to optimize this program, aka this program. Should I make it such that I can deploy from here as well? Defnet deploy. Wait, what? Oh, I mean, it's a nice program ID, but it deployed it to somewhere else because in my deployment, the key pair points to this program. Okay, fine. Export this thing as well. Nice. Now I deployed it here. Wonderful. Cool. I can also deploy it from local. Wonderful. So we can keep working locally here. We don't need Playground anymore. I mean, it was tough enough to set it up to make it work locally. Don't worry if it takes you some time. It took me like an hour to get that done. This stuff is not trivial. That's why Playground is so simple, but you can't do everything in Playground. And sometimes it's just also nicer to work locally. Anyway, I'm gonna take a break now because I'm already exhausted and I can't be bothered to optimize this anymore, but I will come back to you tomorrow. All right, new day, new attitude. Today, we're gonna actually optimize this code that we got from past self. By the way, if you want to try and do that yourself as well, I'm gonna upload that program to GitHub and you can try yourself how much you can optimize it without changing the functionality of it, assuming that there are no bugs in this program. Maybe there are, who knows. So let's get started, let's do this. So I have the program code locally as well, I can deploy locally, and I have client code that will put both of the instructions into a transaction and then simulate it such that we get the compute units. Now it's 64K. Wasn't it 69 yesterday? Did I change some stuff since then? Oh, because of the memo length. If I put a longer memo, then of course it will take more compute. Like now I'm at the 100K. So of course it depends on the input data, but such that we have a reference, I will always use the same thing. So now let's go with this is the memo. And then it will take 68. 70. Damn it. Okay. Let's stay with this. We round up. This is 69K compute units. And we want to get it down significantly. And we will get it down significantly. Because really it's not that difficult of a program. So let's get started and look at the program code. So when we make it a bit small and look at this, what we see is that there is a lot of logging happening here. And the first thing I would do is just get rid of those logs. Like even just getting rid of those 3 will decrease our compute. Well, not even that much. Oh, haha. Why not? Well, of course, because you gotta deploy it. Okay, so deploy. I will forget this several times today, I'm telling you. And then I always need to wait. I should really work locally. Or is there no change? Oh, guess what? Because I forgot to build before I deploy. This will also happen several times. But now, instead of 68K, we need 56. Wow. That is a significant reduction, and I just did it for one of the 2 instructions. The second instruction also still logs the program successful and program started and all this useless crap. Like those messages are really not necessary, are they? Let's validate this memo, let's validate the owner. Like why do you have that in the code? You don't need that. Because if the program goes through, it goes through. It's great for debugging, yes, but for production, get rid of your messages. Like owner valid. Yeah, great. If it's not valid, we get the error anyway. Again, great for debugging, but it's just, I mean, some things you want to log. Okay, maybe you do want to log if the memo is valid. Fine, I'll let you do that. But especially the program successful and the program started, we don't need that because if we have a look in the logs, we see that our program gets invoked. Anchor even logs for us the instruction, so we don't need to do it again. And then for success, we also get that. We don't need to do it ourselves manually here one more time. And then here as well. This is a pretty useless log because we get it from Solana logs, like native logs anyway. It prints the compute units and it prints that this was successful. So it got out of the CPI, or in this case, got out of that instruction is done. This is already in logs. We do not need that. And if we get rid of all of those unnecessary logs here, and we build and deploy this again, we can save compute units from 56 to, well, from 56.6 to 56.1. Okay, so we didn't save that much, but we saved a bit just from commenting out those 4 logs. So the first thing we want to note, remove unnecessary logging. Saves us some compute. And it might be a bit annoying to always, simulate and then compare the units consumed. If you're wondering if there's a better way to check how much compute a certain instruction or a certain part of your code needs, there is a way to do that. So it's not just remove the part of code and build and deploy and run it again. There is a function for it. Let me check. How to optimize compute usage. That's the article. And this video is roughly based on this article. I have some more things that I included in my analysis here, but that is definitely a good resource to get started with the motivation. And then here, how to measure compute usage. There is this compute function that I actually don't know what it does, but we can just try it. What I want to figure out is how much does such a simple log require in terms of compute. And you don't know that macro because I need to import it from where? Do I need to define that macro myself? Or they also just export that macro manually? All right, let's do that. I mean, this again adds code and we don't want to keep this for production. This is just for development. You want to throw that out later. Because basically what it does is it logs the compute units before and then it logs the compute units after, such that it makes it easier for you to calculate the difference. Yeah, and basically executes all the code that you put in. So this macro will basically log before and log after, and then statement with no effect. In this case, we don't have a return value. I'll just ignore this warning. Also, it's not like it's super important that we have that, because again, all it does some simple logging for us. So that simple log, those are the things that it prints. We will see, however, that the total compute goes up because of all of that weird logging that we do just to log how much this individual log here needs in terms of compute. And here we can calculate from, it prints the remaining, so we need to calculate this minus this. Approximately 300 to approximately 500 is approximately 200 compute units is what a single program log takes. And it probably also depends on the length of that string, etc, etc, etc. So if we were to log something ridiculously long, it's not how you spell it, but that's how I spell it. Now, oh, it is actually also still the same. Yep, stays the same. It's not actually dependent on the length of that string. Whatever. So it does not depend on the string length, apparently. However, what we've also seen, it does depend on the string, how it is built, because building the string is also a significant part of stuff that we do for logging. So let's not do that and have a look at this thing here, because this is also just logging that we did, but it's way worse than logging. It's logging a string that we concatenated. So let's conclude number 1, logging, and go to point number 2 of things we can optimize, and those are string concatenations. String concatenations are bad, or at least they use quite some compute. Let me demonstrate. Without this memo, we are at 5.6, and with this one, if I put it in, deploy and run, we are at 6.7. So this instruction alone is 10k compute. 10k for that log. Well, no, not for the log, for the string concatenation of that log. Because first of all, we build this string, then we concatenate the public key, which is also not ideal that we build a public key, but we'll get to that in a second. And then we concatenate once more the memo. Because the way strings live in memory, right, they're one part. You can make reference of that string and get parts out, that's cheap. But if you want to put 2 strings together into one, basically you need to make a new one, a third one, and then copy this one and copy this one. And copying individual characters, that's effort, thus requires compute. So this whole concatenation of that string is not particularly efficient. My assumption is it's cheaper for me to do 3 logs than it is to do 1 log with string concatenations. But I want to have the same outcome. So what I would need to do is I say mem created by, I log the key, and this, I'm not sure if for this it will also do string concatenation. We will need to check. Then I print the memo. The memo doesn't have any of those things. Otherwise it wouldn't be valid, so I can't just do that. Again, not the safest thing to do, but it's fine, right? So we just log a string, then the key, another string, and another string. This, we will still talk about that. Hold on, the key will also, I can also just directly print the string, right? To string. There we go. So we now directly log the strings and we don't have any string concatenation anymore. Let's see if that stuff is more efficient than this stuff. 67K is what we are up against, 67.9. And now with the newly deployed version, where we don't have string concatenation, we have 67.5. Even though we have 4 logs instead of 1, it is cheaper to do it that way. Which, I mean, functionality wise, it's not the exact same anymore because it now also prints it, differently and definitely does not look as nice anymore than if I had that in 1 line, granted. Especially this one is so useless. But yeah, we got rid of the string concatenation. So it is, at least from a CU perspective, better to do it that way. From a user perspective, probably not. And also, it doesn't make that much of a difference. The best thing would be to get rid of this entire thing completely. But before we do so, I do want to discuss this part. So let's just log memo created by this guy. This is what we analyze. Getting the pub key and then the toString, which is indirectly called when we put it into a log. What that does for the key is it base 58 encodes it, because that's how we're used to public keys, base 58 encode. And base 58 encoding takes compute. Encode pub key. Let's see how much compute it takes. So this encoding the pub key 37 to 38. So 11,000 compute units. Just for the encoding of a pub key to get this. And that's why the first time we commented out some messages, we saved so much. Those were the 11,000 for the encoding of that pub key. So if you really need to log a pub key, there is a nicer way to do this, which goes like this, .log. I don't actually know what it does, but it's certainly more efficient. 56. Wow. Versus 67, which is again our 11K. And the log prints the pub key. Wow, what? It does the encoding, but it somehow prints me the base 58 encoded address. Wow. But it uses 10K less compute. Nice. So that's definitely something that we can do to optimize for compute units. Whenever we log a public key, use the log. Best case, still you don't log anything, but if you really need to log that for whatever reason, use that log. Cool. So that's point number 3. When logging pub keys, use this function. And before we continue any further here, I want to say goodbye for now. I don't want to make this a 2-hour video, so I'm going to split it in 2 parts. So make sure you are subscribed for part number 2. Like this video, watch the other ones, and here you will find part 2 if it has already been released. See you there.